Hi everyone, welcome to another video by Maths with Sarah. So today we're going to be taking a look at this question where we've been given a histogram of distances that 80 competitors jumped in a long jump competition. We've been asked to calculate an estimate for the mean distance jumped. So if we take a look at this histogram, we've got distance jumped in meters on the x-axis, and then on the y-axis we've got frequency density. So as with histograms, rather than like a bar chart, we've got the exact numbers. With a histogram, we've got frequency density, and then the area of each of these bars represents the number of people that are in that category, in that distance category. So in order to tackle this question, we need to start by working out how many competitors are in each of these bars. And then we can work out from that, use that to work out what the average is. So if we take this bar here, we can see that it's 10. So the frequency density is 10, and the distance is 7.2 take away 6.4, which is 0.8 meters. And so if we multiply those together, then we're going to get an answer of 8. So there are 8 of the competitors fall into this distance category between 6.4 and 7.2. So now if we do exactly the same for the next one, this one was 50, the frequency density is 50. The middle distance is, the distance category is 0.4 meters. So if we multiply those two together, then we get an answer of 20. And this one, the frequency density is 100. And if we multiply that by the mid distance, sorry, not the mid distance, the distance involved in this category, which is 0.4, again, the same as the previous bar. If we, my mouse is doing all sorts of strange things there. If we multiply those two together, then we get an answer of 40. And then for the last bar, this one here, the frequency density is 60. And if we multiply that by the distance that this bar covers, it's from 8.2 to 8, or 8 to 8.2. So that will be times by 0.2. And if we do that, then we get an answer of 12. And so now at this point, we can stop and check whether or not the maths that we've done so far is correct. So by adding up each of these, we should get an answer of 80. So we've been told there are 80 competitors. So we know that the total frequency density, or the total frequency, should add up to 80. So if we do 60 plus 20 plus 8 plus 12, we do in fact get 80. So at this point, we can be fairly sure that the maths that we've done so far is correct. So now we need to, this is where we start to do the estimating. We need to make an estimate for the mean distance. So for each of these bars, if we take the central point, so say for this first bar, the central point will be 6.8, and we multiply that by the frequency for the frequency of that bar. So in this case, this first bar would be 6.8 times by 8. And so that gives us kind of an average for all the people that are in this bar. It gives us an average of what their distance is. Now, obviously, there are some potential issues here. For example, we could have actually all 8 of them could have jumped kind of 6.5 meters, 6.4, 6.5 meters, and be right down at this end. And so this is why we're being asked to calculate an estimate rather than the exact mean distance. So we haven't got the exact distances that each of these people jumped. But this way is a good approximation, and we can generally take that the average would be reasonable. So if we do 6.8 times 8, then we get 54. Sorry, I've put the point in the wrong place. We get 54.4. And then if we do the same for the next one, we know that it's the midpoint of this bar is around about 7.4. And so we'll times that by the number of people that we know are in this bar, which we know is 20, is the frequency. If we do that, then we get 148, Do the same for this one. So again, we know that there are 40 people that jumped a distance in this bar, and the kind of middle distance for this is 7.8 distance here. And if we do that multiplication, then we get 312. And lastly, if we take this bar here, so the midpoint would be roughly 8.1. And we've calculated that there are 12 people in that frequency bar. Again, if we do this one, we get 97.2. So now if we add all of these up, we get a total of 611.6. So as with generally calculating the mean, the last step will be add it all together and divide by the frequency, or the total number of competitors. So in this case, that will be divided by 80. And if we do that, luckily you get calculated for this, because that is not a sum that I would like to do in my head. We end up with 7.645. That's of course in meters. So at this point, we've got an answer. We then need to go back, or I would suggest that you always then go back and check that that roughly makes sense. So if we were just going to kind of eyeball an average for the mean, we know that we've got a number of people that fit into this category here. But equally, we have got some that jumped further. So the chances are it's going to be roughly somewhere in this bar, so probably between 7.6 and 8, because we've got quite a lot of people that have jumped these longer distances. But it's probably going to be reasonably close to this end. So a distance of 7.645 is probably reasonably accurate, because that's kind of getting this point here, which is of course close to the middle. We could actually have counted all the squares and then found a midpoint there, but I think this way is a really good way of doing it, because it just gives you a good, a much closer estimate for a mean distance. The histograms, I think, can throw a lot of people, because you've got this frequency density rather than having an exact number, and then you have to use that to work out area and stuff. So it just is one step more complicated than, say, calculating an average mean for, say, a bar chart or anything like that. This just takes it a little bit a step further. There's a few extra steps involved. So it's just, the most important thing is just remembering that you need to calculate the area, and then you have to do everything with the area rather than what this is measuring. And you can understand why that's done, because obviously this bar contains 8, and actually that bar is very similar in size to this bar here. It's just obviously this one is a wide bar that's not very high, whereas this one's a high bar that's not very wide. Okay, so hopefully that made some sense. Hopefully that kind of helped you to understand a little bit about how we use histograms. This is one of the questions from the back end of the paper, so it is it's not the easiest of questions, but equally I definitely think that most people, as long as you remember that you need to start by calculating the area, I don't think there's anything that anyone will go too far wrong with. So the next video that I'm doing is looking at another ratio video. I found a really nice question that, again, kind of looks at ratio in a slightly different way from some of the more normal standard questions. So if you want to see that video, then I encourage you to like and subscribe to this video and to my channel, so that then you can find out first about all the videos that are coming out. So lastly, thank you very much for watching, and hopefully there'll be more videos out soon.